आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello students, let's discuss the question. The product of length of perpendicular from any point on the hyperbola x square minus y square equal to 8 to its asymptotes is. So let's begin with solution of this question. So what we will do, we will compare this hyperbola with the standard equation of hyperbola and then we will proceed to answer. So our standard hyperbola equation is x square upon a square minus y square upon b square and this is equal to 1. This is the standard hyperbola. And our given hyperbola, so let's divide this whole equation by 8. So our given hyperbola will be x square upon here will be 8 minus this will be y square upon 8 and this is equal to 1. This is our given hyperbola. So from here this capital A square, this will be equal to 8. Similarly this capital B square, this will also be equal to 8. Now what we will do, according to our question, we have to find the product of length of perpendicular from any point on the hyperbola to its asymptote. So we will solve this question for this equation and then we will just substitute this a square and b square. So from here I can say that the equation of asymptotes can be found by using the concept that is equating the highest degree terms to 0. So we will get the asymptotes as for this hyperbola they will be x square upon a square and minus y square upon b square. These will be the asymptotes equal to 0. So for this hyperbola I will give the asymptotes as x square upon 8 minus y square upon 8. This will be equal to 0. So from here this asymptotes will be equal to x minus y equal to 0 and another asymptote will be x plus y equal to 0. So now we will define any parametric coordinate on this hyperbola and then we will proceed to get the length. So let any point P on this hyperbola, so this can be written as 2 root 2 sec theta and this will be 2 root 2 tan theta. This will be the any coordinate of point P in the parametric form, and this if we will substitute this point P in this hyperbola equation, then it will satisfy the equation, because 2 root 2 sec theta, so on squaring this will get 8 sec square theta and divided by 8, so this will be 1, and similarly this 8 tan square theta upon 8, this will be 1, so sec square theta minus tan square theta, and that will be equal to 1. So this satisfied this hyperbola, that is this given hyperbola. So basically these are the parametric equation of the point on hyperbola. So now we will just find the perpendicular distance on these two asymptotes we have found, that is x minus y equal to 0 and x plus y equal to 0. So first I will teach you how to find the perpendicular distance of any line from any point. So let any line is given to us, that is ax plus by plus c equal to 0. If this is any line given to us, and any point p x1 comma y1, if this is any point p given to us, so perpendicular distance of this line from this point is given by d, and this will be equal to ax1 plus by1 plus c upon root of a square plus b square. This is the formula for perpendicular distance. So what we will do, we will just find the length of perpendicular on these two asymptotes from this point. So for the first asymptote, that is x minus y equal to 0, so our line 1, that is x minus y equal to 0, the perpendicular distance d from this point is given by d equal to, or we can say d1, this will be written as 2 root 2 sec theta minus 2 root 2 tan theta and divided by this a square plus b square, which is coefficient of x and y, so that will be equal to 1 square plus 1 square, that will be equal to 2. So this is the first distance. Now our second distance, that is d2, and this is for our line second, so let's write here l2. So l2 is x plus y equal to 0, which is the second asymptote of this hyperbola. So d2 second distance, this will be given by just substituting these 2 points in this equation and this formula using. So this will be 2 root 2 here and sec theta, and here will be plus sign, so this will be 2 root 2 tan theta here, and this will be in the denominator, there will be square of coefficients, so this will be 1 square plus 1 square, that will be also equal to 2. Now we have to find the product of this d1 into d2, so d1 into d2, so this will come out to be, just take this 2 root 2 common, so 2 root 2 common, this will be 2 root 2 into here will be sec theta minus tan theta and this will be divided by this root 2. Similarly, multiplying this d2, so d2 will become 2 root 2. Here will be sec theta and here will be plus tan theta, and in the denominator there will be a root 2. So from here, cancelling this root 2 with this root 2 and cancelling this root 2 with this root 2, and here we get 4 into here will be, here we get sec theta minus tan theta into sec theta plus tan theta, so that will be sec square theta minus here will be tan square theta, and this value is equal to 1, that is sec square theta minus tan square theta. So d1 into d2, this d1 into d2, this will be final come out to be 4, that is this value becomes 1. So answer to this question will be option D, that is 4. The value of this product of perpendicular from any point to asymptote of this hyperbola is equal to 4. So this will be option D. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।